Hello, students, again. Thank you for joining us for lesson 10.7, day 2. Again, shout out to Miss Dang and Miss Fung's class joining us for adding and subtracting scientific notation numbers. Remember, that's not hashtags, that is numbers. There are a few word problems today that you might be doing as well with the addition and subtraction, but you did a few word problems with the multiplication and division as well. So let's go ahead and reiterate that a scientific notation number answer has to make sure that the first part has to be between 1 and almost 10. It's like a 9.99 is good, 1.2 is good, but anything less than a 1, like a 0 point, not good. Greater than 9.9, like 10 point something, 12, 20, something like that, not going to work out for us. So just keep that in mind as you are finalizing your answer. To actually add or subtract, we're going to show you two methods. It says the exponents must be the same number. So there's going to be a little bit of changing around so that you can actually have the exact same exponents. That is a certain method. We'll show you an additional method in case that one's a little bit too challenging for you. All right, so let's see. Method 1, we are going to use those rules, scientific notation rules. So you've got looks like two big numbers here that we need to go ahead and add together. But if you notice, your exponent is not the exponent that we want for that first quantity. You got an exponent of 2. We need both of them to have an exponent of 3. It's a lot easier to change your smaller exponent into the larger exponent. So again, exponent 2 is going to change into an exponent of 3. So the way we're going to do that is we are going to move our decimal, because remember, when you move your decimal is when you're allowed to change your exponent. So we're going to go ahead and say that the exponent of 3, again, that part can stay the same, but on the 3.4, go ahead and put your pencil, second color, whatever you're using, at that decimal point for the 3, and we need to go ahead and move it. Now, the way we're going to do that is making it a smaller number so that we can have a larger exponent. So again, some students get that pretty easily, others not so much. Method 1, we're moving the 3.4 into a 0.34, but it has a larger exponent. Now we notice that they have the exact same exponent, so we can add them together. So if you have to, you go off to the side and you line it up like in elementary school, kind of like $4.57 plus $0.34. You just add it up and you get $4.91. But of course, it's not really that because it has an exponent of 3 for our scientific notation answer. But if you notice, the 4.91, that is an acceptable answer because it's between 1 and almost 10. So again, the little trick is to be able to get them to have the same exponent. You're going to change the smaller exponent into the larger. So on this one, we only had to move once. Sometimes you have to move it twice, just depends on what the exponents are. So the 3.4 became a 0.34. Now, if you didn't like that method, then we have method number 2 for you. Method number 2 is saying, you know what? If you're not the greatest at the operations for adding and subtracting, because it's actually more challenging than the multiplication and division for scientific notation, is to go ahead and change your numbers. So remember, like what we did at the very beginning of scientific notation, we practice writing scientific notation in standard notation. So on the first one, where it says 3.4 times 10 squared, I would move my decimal 2 places to the right. On the 4.57, I would move my decimal 3 places to the right. Again, they're both big numbers because they have a positive exponent. That's why we're moving it to the right. So it really becomes 340 plus 4,570. So you'd have to add those together. Again, you can go to the side, line them up, and you get 4,910. Now, if you notice, this is obviously a standard notation answer, but we really want it in a scientific notation answer. So just like day number 1, our decimal point is at the back, and we need to go ahead and move it so that we can get it into its correct place. So if we move it once, not good enough. Move it twice, not good enough. You got to move it so that's between the 4 and the 9. And in doing so, you move it a total of 3 times, which is why we have the positive exponent of 3. So some students really like method number 2. Gives you a little bit of extra practice with writing it in standard notation from scientific notation and going backwards to standard notation to scientific notation. But sometimes our numbers get a lot larger than students are ready to do, meaning there's so many zeros involved that their alignment gets a little bit messed up, which is why, if you can, we encourage you to use method number 1. But again, method number 2 is available if you need it. All right, when you subtract, it's pretty much the exact same thing. We need to go ahead and change the smaller exponent into the larger exponent. Now, on our previous example, both were positive exponents, so it's a lot easier for students to recognize the smaller exponent. So you should be asking yourself, which exponent is smaller, -5 or -6? Talk with your partner real quick. Remember, on a number line, the -6 is further to the left of -5, so it means -6 is technically the smaller exponent, which means that's the one we got to change. So the way we do it again is we move our decimal. This time is just having to move one place because the difference between a -5 and -6 is only one space on a number line. So we're just going to move it one space. And in doing so, it is now going to be a -5 for the exponent. So they have the exact same exponent, so therefore we are allowed to subtract. If you need to, go ahead and line up your $8.41 and go ahead and subtract $0.79. Again, I know it sounds pretty basic that way, but I constantly think about money when we're talking about decimals like this. You can line it up and subtract. Some students are very proficient with money thoughts, so they can do the subtraction in their head. But if not, again, just line it up and subtract like you did in elementary school. In doing so, if you notice, we have an acceptable answer of 7.62 times 10 to the -5th power. Now, I can't guarantee that it's always going to be like that, but if you notice, the two examples that we did so far, they do have nice answers at the end. We don't have to do any extra movement of decimals. Again, not always guaranteed. So, method number 2. Again, this is maybe why some students may not want to do method number 2, is because if you notice with your exponents, you have to move it several times, which means you're going to have several zeros that you're going to have to line up. So for the first one, 8.41, you're going to move your decimal to the left 5 spaces. And then for the 7.9, you're going to move your decimal to the left 6 spaces. So it's like this. When it's presented to you like that, some students may have a little bit more difficulty in lining it up and then doing your proper subtraction. So again, there's pros and cons to each method. You're going to have to kind of decide which method is best for you with your personal thinking. When you subtract, you get the 762 like the previous answer. But again, if you notice, it's in its standard notation. So you got to practice moving your decimal a bunch of spaces, which is how we get that -5th power. So again, you're going to decide what's best for you. But when we do some homework help, we're going to go ahead and stick to method number 1. If you want to do method number 2 on your homework, just make sure your final answer is in scientific notation. All right. Quick word problems. As you're reading the word problems, you're really just going to decide, okay, do I have to add or do I have to subtract? And if you notice on this one, we gave you the same exponent, so you don't have to do any changes there. So let's see. A flight from Singapore to New York includes a stopover at Hawaii. The distance between Singapore and Hawaii is that number. 6.7 times 10 to the third miles. And the distance between New York and Hawaii is this. All right, so we're going to have two problems that we're going to go ahead and structure. The first one is finding the total distance. So the total distance from Singapore to New York is actually going to be adding the two flights together. And if you've ever had a layover, you know that. Again, you got to stop somewhere, got to go ahead and take a break, hopefully catch your next flight. But again, you're going to be adding the miles together. So the great news is on this one again, the exponents are already what we needed, 10 to the third power. But if you notice, when you add the numbers in the front, the 6.7 and the 4.9, your result is not what we want. That's going to be too great because again, that beginning part of our scientific notation answer has to be between 1 and almost 10. So when we add it together, it gives us an 11.6, which is not what we want. So we need to practice what we've already been talking about. We're going to move our decimal one place, and it'll give us an exponent of 4. Because again, 11 is greater than what we really want, which is kind of like adding an exponent of 1, which is why it's now an exponent of 4. It's a lot of miles traveled. So the last thought real quick, just going to show you don't have to write everything down. The quick subtraction one, same exponents. We just need to go ahead and subtract it. And when we subtract it, it gives us a nice, beautiful number, 1.8. Just showing you the difference that sometimes when you add, maybe even when you subtract, it depends on the problem, is you might have to change it at the end. All right, going to ask our subs to go ahead and pause the video and pass out the worksheet, please. And welcome back. Let's go ahead and do a little bit of homework problems to help you out. Now, if you notice, some of the beginning problems are actually repeats from yesterday, meaning you got some multiplication here on 1 and 2, division on 3 and 4, multiplication on 5, division on 6. So those are repeat problems. Let's go ahead and focus on the ones that we are discussing today that are new. Now remember, regardless if you are adding or subtracting, you have to have the same exponents for method number 1. If you choose method number 2, you're going to rewrite it into standard notation, add or subtract, and then you're going to have to go ahead and change it back into scientific notation. Now, if you notice on number 7, there is a difference of just one exponent between a 5 and a 6. So that means you're going to move your smaller one, which is the exponent of 5. So you're going to move your decimal just one place. So that would give us a 0.73 times 10 to the 6th power. And you're going to add that to the 2.4 times 10 to the 6th power. So as our notes showed us, it's going to stay as 10 to the 6th power. And then you just got to go ahead and add it together. So again, my teacher taught me, put the greater number on the top, other number below, and just add them together. So it's going to be a 3, an 11, 3.13 using method number 1. Well, 3.13 is an acceptable answer, so that means we are good there. Now, when you only have to move it one space, a little bit easier, but look at number 8. Number 8, you have an exponent of 8 and an exponent of 5, which means in order to change this exponent of 5 into an exponent of 8, then we're going to have to move our decimal 3 spaces. So let's see, 1, 2, 3. And if you notice, we've got extra zeros there. So that's really going to be a 0.0059. And now it's going to be a 10 to the 8th power. It looks like it's an addition problem. 1.357 times 10 to the 8th power. So again, it doesn't matter if you have an addition or subtraction problem there. We just need to go ahead and make sure that they have the same exponent. So it's times 10 to the 8th power. So really you just need to add those up. So let's go off to the side. 1.357. We're going to line up our decimals to be 0.0059, which means we're going to put an extra 0 there. Add them together. So let's see, a 9, a 12, 6, 3, decimal point 1. So we've got a 1.3629 times 10 to the 8th power. So again, it's all in how many times you have to move your decimal, and it's really just what's the difference. The difference between 5 and 8 is 3, so you got to move your decimal 3 places. This one here, a subtraction, we'll do this one. We got to move our decimal 2 places because, again, the difference between a 7 and a 9 is 2. Now remember, if you don't like this method, you can try method number 2, which is putting them into standard notation and then subtracting. All right, so let's see, decimal point here, move once, twice, extra 0 goes there. So that is a 0.047 times 10, and again, the exponent is now a 9. 1 times 10 to the 9th. Our answer is going to be 10 to the 9th power. And then go off to the side. Now you notice you got some decimals, so let's go ahead and write it as 1.00. The other one is 0.047, so that means I need an additional 0 there. And got to subtract. All right, let me zoom in for our Vision Challenge friends for this wonderful subtraction. So based off of your awesome skills, remember this becomes a 0, that's a 10, cross that off, that's now a 9, so that's a 10, cross that off, that's now a 9, so this is a 10, there we go. 10 subtract 7 is a 3, 9 subtract 4 is a 5, 9 subtract 0 is a 9, and then we've got our 0. So we've got 0.953. Now, if you notice, this answer is unacceptable because our result here is less than what we want. So I'm going to grab my second color. I'm going to move my decimal 1 place. So that's now going to be a 9.53 times 10. But the question is, are we going to add one or are we going to subtract one? Now, what I tried sharing previously is when the number was greater than it was supposed to be, that would be adding the 1. But if the number is less than what it's supposed to be, that would be a subtracting 1. So our result would now be with an exponent of 8. So it's a little bit of trickiness in here. We got to make sure we have the same exponents to add or subtract. And then at the end, is your answer acceptable? If it's not, you got to change it up. Like again, number 8 here, that was an acceptable answer, but number 9 was not. So you're going to be working on those with your addition, subtraction. And then on the word problems here, you got to figure out, again, what is your actual operation? So last year, this amount of people visited Bubba's Boot Barn. This year, it is more popular with those visitors. How many people visited this year and last year? So in other words, we are looking for our total together. Sorry, the light. Which is really going to be an addition operation. But if you notice, they currently cannot be added using method number 1 because they have different exponents. So it means you'd have to change the exponent 5 into an exponent of 6 and then add it. Very similar to what we did on the previous ones. All right, number 17. We've got this, the largest attendance record. Last year, this was the attendance record. How many more people attended on the record day? So this is a difference problem, which is a subtraction problem. If you notice, they do have the same exponent. Fantastic. So no changes required there. But when you do your subtraction, is your answer in the correct result or answer form that we're looking at? I'm thinking it might not be. So verify it when you do your subtraction. Remember, if it starts with a 0, it's not going to work. All right, you're going to rock this. Do the best that you can. We'll spend some time reviewing tomorrow. Have a great day. Be awesome.